Hey everyone, welcome back to the channel where we break down maths topics the easy way. In this video, we're looking at transformations of graphs, how to move them, stretch them and flip them, all without getting lost in the maths. Let's break it down. To start off with, let's look at translations, i.e. sliding the graph around. There are two main ways to translate a graph. The first is if we've got a number outside the main equation. For example, f of x plus a. This moves the graph up if a is positive and down if a is negative. Think, plus outside moves it up or down. For example, on the screen we've currently got the equation y equals x squared. If instead we had y equals x squared plus 2, this moved the original graph up by 2 units. And so we get a resulting graph that looks somewhat like this. This means that the parabola has been moved up by 2. The next type is if the number is inside the original equation, of the form f of x plus a, where the a is inside the bracket. This moves the graph left if a is positive and right if a is negative. It sounds a bit backwards and a bit counterintuitive, but that's just how the maths works. And once you've had enough practice, it will become second nature to you as well. For example, sticking with the x squared example, if instead we had y equals x plus 2 all squared, this moves the parabola 2 units left because the a in this equation is positive. This means we end up with a graph that looks something like this, that has been shifted 2 units to the left. Now let's take a little look at stretching. Stretching means you go wider or narrower according to a particular axis. If your equation is of the form af of x, this stretches the graph vertically, i.e. along the x-axis. Suppose we start off with the graph y equals sine x, which I've drawn for us in red. If we then had af of x, so supposing we times it by 2, y equals 2 sine x. This makes all the y coordinates bigger by 2. A general rule of thumb is that if the a in front of the equation, the number in front of the equation is greater than 1, the equation gets bigger, the values get bigger. And if a is less than 1, then the y values get smaller. As you can see, the a value in this case is 2. So all of the values are doubled, and we end up with a graph that looks something like this, because everything of the y values have been doubled. It's now twice as tall. The second type is if the factor is inside the original equation, of the form f equals ax. This stretches the graph horizontally, i.e. along the x-axis, by a factor of 1 over a. Again, a little bit counterintuitive, but with enough practice, you'll get the hang of it. If a is bigger than 1, it shrinks the graph, it squashes the graph in. And if it's between 0 and 1, it stretches it out. For example, if we have y equals sine of 2x, this has squashed the graph together because a is greater than 1. This means our new graph looks something like this, as it's all been squashed in. It still has the same peaks, but the peaks come quicker. Finally, let's take a look at reflections. Reflections are like holding up a mirror. To start off with, if you times everything outside the brackets by the number, you'll flip the graph over the x-axis. All the positive y values become negative and vice versa. For example, sticking with y equals sine x, if instead we had y equals minus sine x, then all of the y values that were once positive are now negative, and vice versa. This means our resulting graph looks something like this, because all of our y values have changed. Next, we've got if the negative is inside the original fraction. This flips it across the y-axis and all of the x values swap. So if they were once positive, they're now negative, and vice versa. So again, let's take a look at y equals sine of minus x. This means all of the x values that were once negative are now positive. So the negatives we can now move to the positive side, and the positives we move to the negative. For a graph like sine x, you won't notice much of a difference, but you'll notice it more in other equations. A key takeaway is to make sure that you flip along the right axis. If the negative is outside, you flip it across the x-axis. And if the negative is inside, you flip it across the y. So remember, outside translations move it up or down. Inside, move it left or right. If you multiply outside, you stretch it vertically. And if you multiply inside, you stretch it horizontally, but the opposite of what you think. And then when it comes to reflections, minus outside is an x-axis flip and minus inside is a y-axis flip. Master these and you can transform any graph in seconds. If this helped you feel more confident about graph transformations, hit like, subscribe for more walkthroughs, and drop a comment below if there's a topic you'd like for me to cover. You've got this. See you in the next video.